Okay, here we have a practice problem. Okay, draw both chair conformations for trans 1,3-dichlorocyclohexane. Circle the most stable conformation. Okay, I'm going to put it on pause. I want you to work on this, and then when I come back, I will show you the answer. Okay, so the first thing, probably the first step to do, the best thing to do, is to first draw out what it looks like in 2 dimensions. I kind of like to do this. You don't have to, but I kind of like to do it. So the trans dichloro, I have a chlorine here and a chlorine here. Trans means they're on opposite sides of each other. So I'm going to be drawing 2 chair conformations. One, the chair, and then the flip version of it. And then I'm going to try to figure out which one is the most stable based on which groups are mostly in the equatorial position. Okay, so let's draw this one. All right, and it's the 1, 3. So I'm going to just arbitrarily number this carbon here 1, and so 1, 2, 3. Okay, doesn't matter which how you number it. That's just what I arbitrarily use. It doesn't matter which one you use. I'm going to also put the axial and equatorial positions in because I know that I'm going to have to put groups there. I'm going to arbitrarily put a chlorine here and a hydrogen here. It doesn't matter if you put the chlorine with a hydrogen here. That's fine, as long as the other chlorine is trans to that chlorine. That's the important part. That's why I said that axial and equatorial have nothing to do with cis and trans. Okay, so since it's trans, the other chlorine has to be at this position right here. Okay, why is that? Well, notice the hydrogen and the chlorine are on the same side, and this hydrogen and chlorine on the same side. So that means these chlorines, if you look, are on opposite sides of the molecule. So that's trans. Okay. So we look at this, and what do you notice? We have an axial chlorine there and an equatorial chlorine there. Let's now do the ring flip. Well, when you do the ring flip, what happens? What was axial here is now going to become equatorial over here. So this is carbon 1. Here's carbon 3. What was equatorial here becomes axial over here. And whatever was axial becomes equatorial. This is now axial, and this is now equatorial. What do you notice? You notice that both molecules are the same. So they're both equally in energy. There is not one that's more stable than the other. In the last case there was, but in this case there isn't, and that can very well happen. So they are same in energy. Same in energy, or equal energy, I guess would be the more appropriate way of saying it. So you don't really have to circle one, I guess, if you want to circle both of them, but they're the same. But the important part is that you understand how to draw these chair conformations, how to put the groups appropriately on the chair, how to draw your axial and equatorials, and how to write them cis and trans. All right, I want to do a chair tutorial. This is kind of extra. Drawing these chairs sometimes can be hard. I have some tricks. Your book kind of has some tricks of doing it too. They kind of show you how to do it. First of all, let's talk about the axial and equatorial positions. Okay, so some people can draw the chair, some people can. I'll talk about how to draw the chair in the first place after this. But the axials, here's how you do it. Whichever way the carbon is pointing, that's the direction of the axial position. So notice these two bonds right here are pointed up. So your axial is straight up. It's not at an angle. Don't draw them at angles. It's straight up. And then if you just keep going around, this bond and this bond, notice, is pointing down. So here's the point. It's pointing down. That's your axial. Basically, if you get one of them, the rest of them are the exact opposite. So this is up. This is down. This is going to be up. This is down. This is up. The one in the back, I kind of down. Okay? But again, it still follows. This is pointed down. So it goes down. This is pointed up, so it goes up. Okay, so that's how you can get the axials. Okay, the equatorials, a lot of people feel it's a little bit harder, but it really isn't. Okay, what you want to look for is a W and an M. Okay, those are the two letters that you're looking for. W and M's. Okay, The W, the tips, this portion right here and that portion right there is the middle part of your W and your M. So this is the middle of the W. So look at my W. You see my W right there? There's my W. This is where your axials go. That's how you draw an axial. This is the middle part of the M. There's my M. So those are the axials for the M. Makes it a lot easier to see now. Now at the tips are, at the tips you just have to know how to do it. The tips are basically slightly at an angle opposite of where it's pointed. So this is pointed up, so I'm going to do slightly going down. Okay, don't go straight across. Because remember, your axial is straight up and down right there. So your equatorial has to come a little down. Since this one is pointed down, your axial is slightly pointed up. All right, so that's how you can do your equatorials on that molecule. Okay? Now, I did have a student once who did have trouble drawing their chairs and everything completely. So he took this W and M and kind of took it a little bit further in order to draw his chairs. Now, I still can't do this. He was able to do it very quickly. If you want to practice this, I mean, I have no idea. I don't care how you do it. Just kind of, make sure it looks good. But if you notice, our W here is like on an angle and the M's on an angle. So he like drew an M like this, and then drew a W like that, and then he connected the lines. And there you go. Actually, that's not too bad. You have your axials already set, and you have your equatorials. I think he did smaller M's. He went like that. Oh, that's a little too long. And then his W like that, and then connected them. That's a little flat. You kind of have to play around like with the angles of your W and M's. So the M has to be a little bit more at an angle. Your W has to be a little bit more at an angle. And then you connect the lines. That didn't come out good, but anyways, that's kind of I think that might help in drawing your axials. I'm sorry, your chair conformations.